The purpose of this video is to discuss how to balance chemical equations. Chemical equations are represented like this, with reactants on the left, products on the right, and an arrow in between. 2 gaseous hydrogen plus 1 gaseous oxygen yields 2 gaseous H2O. That's how you would state this chemical reaction. We have the formulas, and that could be for a compound, but it could also be for elements. These are the formulas for hydrogen and oxygen. You have the big number, which is called the coefficient. This means that I have 2 H2s and I have 2 H2Os. There's nothing here, so that means 1. So 2 hydrogen, 1 oxygen, and then 2 H2O. You have the small number, the subscript, that tells you how many elements there are for that particular element, or sometimes if it's in parentheses, it might be for the whole compound in parentheses. So I have 2 hydrogens, but since my coefficient is 2, that means I actually have 4 hydrogens. And then you also have your state of matter. State of matter could be solid, liquid, gas, or aqueous, which means that it's dissolved in water. So before we get into balancing equations, we have to talk about the law of conservation of mass, which states matter can't be created or destroyed, so the mass of your reactants has to equal the mass of your products. And we balance chemical equations to represent the law of conservation of mass. Here's an unbalanced equation. You'll notice that carbon is unequal on each side of the equation. We have 3 carbons versus 1. We have 8 hydrogens versus 2. We have 2 oxygens versus 3. But if we balance it by changing the coefficient, then we have an equal number of each element on both sides of the equation. Let's look at an example. Now this is the strategy. You want to start with the unbalanced equation and then list everything in that equation. You have hydrogen on both sides, you have sulfur on both sides, you have silver on both sides, and then you have nitrate on both sides. Sometimes you can write the polyatomic ion like right here, NO3, but sometimes you might want to just list it N and O. That's up to you. I did it like this because nitrate is the same on both sides. It doesn't break up at all. So let's count. I have 2 hydrogen. I have 1 silver. I have 1 sulfur. I have 1 nitrate. On the other side, I have 1 hydrogen, 1 sulfur, 2 silvers, and then 1 nitrate. You notice that they are unequal, right? So we can change the coefficients to make them equal. If I change this to 2, that gives me 2 silver, but it also gives me 2 nitrates. So I change over here to represent what had changed when I changed that coefficient. Obviously my nitrate's uneven, so I need to add a 2 here. When I did that, now I have 2 hydrogen and 2 nitrates. So 2 hydrogen, 2 nitrates. Now let's see, are we balanced? 2, 1, 2, 2. Totally balanced. Example. SO2 plus O2 yields SO3. Obviously that's not balanced. So I want you to pause the video and give this a shot on your own. Okay, let's see. If we change the coefficient to 2 on SO2 and SO3, that gives us 2 sulfur plus 4 oxygens, and then another 2, so 6, 2 sulfur, 6 oxygen. What do I have here? 2 sulfur, 6 oxygen. Okay, next, this one's a little bit more complicated. Same thing, pause the video and attempt it on your own. Okay, so we have 2 H3P, 3 CaOH2, And then this stays the same. It's going to be 1 and then 6H2O. Let's count. 6 hydrogen, and I have 12 hydrogen over here. Oh, wait a minute. Look at this. I have hydrogen on both. So sometimes this will happen. You'll see that hydrogen is split up into two different compounds here, right? So we have to count those separately. So I have 6 hydrogen, and then 3 times 2 is another 6 hydrogen. So 6 plus 6 is 12, and I have 6 times 2, so 12 hydrogen. I have 2 phosphorus, 3 calcium right here, 3 calcium right there, and then oxygen. 3 times 2 is 6, and look at that, I have 6 oxygens. Okay, that's all you got to do.